What's up, guys? It's Jamar again, and in this video, I'm going to be covering different types. Um, so types in any programming language is basically um, different kinds of data. So we can have numbers, we can have words, um, more precise numbers like decimals, um, like true or false, which is a Boolean. We can have like just single character. These are all called primitive types, and basically, that's what I'm going to be showing you how to do in C. So you might notice in Python we'll do something like let's say like new number, and we'll say is equal to like 1, for instance, with no semicolon. But in C and most other languages as well, we would do int new number is equal to 1, like that. Now this semicolon here basically lets the compiler know, okay, this line is done. Now it's time to go on to this line here. So we can even put everything on one line. I can say int uh, second num is equal to 2, and so on and so forth. But usually with programming, you want to put them all on separate lines. Um, so basically, we want to indent everything because it makes our code look neater. So let's just say we want to pass this int into a printf string. So we can just simply do, once again with our format, I'll just say the number is, and then I can do %. And we can do either I for integer or D. And I'm going to show you that both work here. So we can do a new number like that. Then if I run it, the number is 1. And then if I change this to D and run it, the number is 1. So both of these work. So I think D stands for digit if I'm not mistaken. And then I stands for integer. And so that's why both of those work. Now, what if I wanted to do a float? Now, a float is basically a decimal or integer, but it'll be a float like that. And for a float, I'd have to say like 1.0, for instance. Now, if I do D, I think I'm gonna get an error, or I actually got 0, right? So if I do I also get 0. Now, why is that? Because, well, it's not a integer. So basically, those two don't work. You don't get an error, but you get like 0, meaning like it's not a value there. Obviously, there is a value. So why is that? That's because this is a float. Now, if we do F, which stands for float, you can see we get 1.0000 and it rounds it off. Now, what if we don't want these extra zeros at the very end? Well, what we can actually do is say point, and then however many zeros we want after it. So we only want 2 zeros after the decimal. We can do a 0.2. Now I know this looks weird, but watch this. Now we only get 2 zeros after the decimal. We want 3. Now we get 3. So basically, that's how this will work. So it's like almost like saying 0 point something, and then doing that, you can see we get the same thing. That's just basically what that's doing. Um, Sorry about that, but that's just basically what that's doing. So that's how you would do that. We also have things like doubles. So we do a double here, same thing, 1.0. And let's just say we try to do a float for that. You can see here we do get the same thing, but usually when dealing with doubles, you want to do LF. That means long float. And if you see, if we run that, we get the same thing here. So that's because LF is long float, which is what a double is. A double is basically there's numbers on both sides of the decimal. So there's like, and because there's always a number on the left side of decimal, even if it's a 0, and on the right side there's like some type of value. So a double always has to usually be a decimal. For instance, if we do a double equals the new number, double new number is equal to 1, you can see it automatically formats it to a double anyway. So that's basically like how this will work. That's just another type. We also have characters, which I don't want to call this new number. I'm going to just say new character. And I'll just say, now for characters, you want to use single quotes. I know in some languages you can use single and double for strings, but it's really restrictive in C where you have to use single quotes for characters. let's just say the character J. You can do whatever character you want. And let's just say we want to do a character, so let's just say C for character. It'll be S for the character array, aka a string. But for a single character, we want to do C. So if we do new character, and we run it, I never actually changed that. Let me just say the character is, you can see the character is J. Now, here's a funny thing. A character is also considered an integer. So each character in I think it's like the ASCII table, ASCII. Each character has a value, even including special characters. So basically, all the lowercase letters and the uppercase letters have their own value, and then all the special characters have a value as well. So a character actually can be read as an integer. So you can do like I, and if we run this, you can see we get 106. So that's the value for a lowercase j. Now here's the funny thing, right? If we did an uppercase j here, we'll get a different value, and that's because uppercase and lowercase have different values here, you know? So, and then I think A or capital A might be the first character. I'm not sure on that. 65, 97. Well, the first character is actually numbers 0, 1, 2, 3, 4. And then after that, that's when it starts to go to the letters and the special characters. But I was just showing you that a character is essentially a number as well. It has a value in the for the ASCII table, pretty much. So that's that. We also have strings, which I showed you earlier. So if we want to make a string, we can say we put square brackets there, and then we can do like if we don't want to put anything there, we can say like 10 or specify the number of spaces this has. Now, what if we input more than just 10? So what if we do like, let's say we want to do, let's see, %s, and we'll do an and like let's say we want to do more than 10 characters here. Well, when we run this here, if I just do more than 10 characters, you can see we oh wait, let me actually change that back. You can see we had a value there, but we don't want that. I think it just adds the values together. But we want to do a string, so let's just say we want to specify the number of characters. It's really just to save memory in the system. So basically, now that I did that, I also want to do Boolean, so that'll be bool. And then I want to say, instead of new string, I want to say true or false. Let's just say is equal to false, like that. So that's alright, so actually we have to use stdbool.h, which is a header file for the Boolean library, basically to let us use Booleans. Now that I remember when I did it in college, I think I did ints of 1 or 0, which you can also do as well, because a Boolean really is just an integer. And so actually, if you wanted to say like another way of doing this, we could actually just do something called a ternary operator. We can do true or false, where, so a question mark, and then we can do if true, we just say 1, and then else will say 0, like that. And if we actually run this, you can see we get 0 because or we would also have to actually put percent s here. I forgot, or not s, but d. Forgot to put that. Okay, let me run that again. And you can see we get a 0. And so now if we set this to true, we get a 1. And that's because basically what we're saying is if this is true, meaning if true or false is equal to true, and I'm going to show you that later, which will also get a 1 here, is because if this is equal to true, then we want to return a 1. And if it's not equal, then we want to return a 0. So if it's false, we return a 0. So that's just something I wanted to do for the types really quickly. I guess next I'm going to cover a little bit of control flow logic and then go into loops. And then once we do that, I'm going to do a quick challenge just to basically um, reinforce what we've just learned. So thanks for watching. If you, like I said, if you don't want to use this std boolean, you can just simply do int true or false is equal to 1 or 0. And you can alternate like that. It does the exact same thing. So thanks for watching. I hope you enjoyed it, and see you later.